All right, we are doing Unit 7-1 notes. We're going to talk about polynomials. And all a polynomial is an expression consisting of many terms. Or it could be a few terms. But, so, a 5, technically, that could be a polynomial. Negative 6x could be a polynomial. 4x squared minus 1, that could be a polynomial. 9x to the third plus 4x squared minus 2x, that could be a polynomial. It's all these little groups, when I have them grouped together, that make a polynomial. When we write a polynomial, we like to write it in standard form. That means when you have when you have variables x, y, z, a, b, they're written in ABC order, and you also write the highest exponent first. So we're going to do some practice to show you how. So I'm going to do these in ABC order with the highest exponent first. Well, there's only x's, so there's no ABC order, but I have an x squared, so 2x squared goes first, then I just have an x, and then I just write the number that doesn't have any variable on it. That is the correct order. We're not doing any math, we're just putting them in the right order. When I look at number 2, I see that 7k to the third is the biggest exponent, then k squared. Keep that minus with the k, minus k plus 64. I'm just putting them in order. I would like you to do 3 and 4 by yourself and show them to me, and then I'm going to do 5 and 6. So alphabetical order, we got A's and B's, so I have to look at the A's first. The biggest A is A to the third. The next would be A squared. The next A would be this 2AB. And this one would be last because it doesn't have an A at all. And don't forget to use that minus. Let's put number 6 in order. CD, so C comes first, so we're looking for the biggest C. Well, right there, negative C to the third is the biggest. And then we'd have minus 7C squared, D squared. Next, we'd have this D, 5D cubed, because it doesn't have any C's in it. And then last, plus 13. This part, we're just going to kind of make notes, and then I'll explain it as we do examples. It's a little hard to explain if not. So, when it says degree, it means the largest exponent. So if a number doesn't have an exponent, such as 8, the number 8 doesn't have an exponent, so it's to the 0 degree, so we call that the constant. All right, if I have a number 4k, well, we know really there's a little 1 right there connected to that k. So if I've got that, that means it's to the linear degree. Quadratic means there's a square in it somewhere. So 3p squared, that would be a quadratic. If I have 1m to the third, that would give me a cubic. Sorry, that I got a little out of control. And then if I have something to the fourth, we call that quadratic. I don't know how to say that. Okay, so those are my degrees. And then the number of terms. Terms are always separated by pluses or minuses. So the word mono means one. So monomial means I have just one term. The word bi, means two. So if I have a binomial, that means that I'm going to have two terms. The word for three terms would be a trinomial. And anything four or more terms, it just gets the generic name polynomial, means many. So let's look at these problems right here and label them. So this one, number 7, it's just a 6. Well, when it's just a straight up number, it's a constant. And then there's no exponent, or there's only one term. So if there's one term, I have a monomial. So a constant monomial. Let's look at the next one. The largest exponent, we know there's a 1 on that P. So the largest exponent I have is a linear. In my term, I've got 2 little groups. So when I have 2, that means it's a binomial. Okay, the next one, I got this little 3, that's my highest exponent. So if my highest exponent's a 3, I'm cubic. And again, I got 1, 2. So it's a cubic binomial. I would like you to do 8, 10, and 12 using your chart above to tell me what's its degree and how many terms are in it. All right, on this next page, we're going to do a little addition subtraction action. And when we do it, it's just like we've been combining like terms. So I'm going to look at my 11x right here. Well, his like term in this other group is this negative 5x. So I have 11x plus negative 5x. 11x plus negative 5x, that makes 6x. All right, let's look at the x squared. So I got negative 1x squared plus, he matches over here with the 2x squared, 2x squared. Negative 1 plus 2 is plus 1x squared. And then 13 plus negative 23 makes a negative 10. Now remember on the other page we were writing them in order, so really I'd want 1x squared plus 6x minus 10 to be your final answer. So I'm just combining my like terms and then writing them all together. This one has a minus in the middle of it. So in the other one when we were adding, this one we're going to subtract. So I've got a 4x squared, and I'm going to subtract him from this 3x squared. Well, that'll give me 1x squared. Then I've got this x. We've used that one. And I've got a 7x. So 5x, I use a minus 7x. 5 minus 7 is negative 2x. Now, I'm out of things in this first one, but I still have a 1 left in my second group. So I'm just going to say there's nothing in the first one. Subtract 1, because I have to subtract because that's what that says to do, and then a 1. So that'd be a negative 1. 1x squared minus 2x minus 1. So I'm going to do one easy one with you and then one harder one with you, and then I'll have you do the rest. So let's do an easy addition one first. Let's do 13 right here. So who has the same last name as x? 4x. So it's x plus 4x. Well, 1 plus 4, that gives me a 5x. And then I've got a 5 plus negative 7. If I type that in my calculator, 5 plus negative 7, I get minus 2. And that's your answer. That's as pretty as it can ever be. Let's look down at one a little more involved. Let's look at 17. So it starts with a number. So 8 plus, because it's got that plus sign, 8's going to match up with negative 15. 8 plus negative 15 is negative 7. Now I've got this negative 1p squared plus p squared. So negative 1 plus 1 is 0. So for this second, I'm going to write 0p squared. And then I have 5p plus negative 4p. 5p plus negative 4p is positive 1. All right, p. We know, though, that when we have 0 of something, we have none. So we don't even write it. So now I have negative 7 plus 1p. Well, to write that in perfectly happy math land language, we'd write 1p minus 7. All right, so those are two examples of addition. I want you to do 15, 14, 16, and 18. I'm going to give you two examples of subtraction, and then I want you to do the rest of those too. All right, we're going to do the exact same thing we did before, except instead of adding the numbers, that middle sign tells me I have to subtract. So 1x squared, his partner, minus 3x squared. 1x minus 3x is negative 2x squared. 17 minus 17x minus 5x. 17 minus 5 is an 11, so plus is a positive 11. 12, it's a 12, my bad. So negative 2x squared plus 12. So do it the exact same way. Let's bump down here and do a hard one, or harder. So I got my v. 7v minus 8v. We got to remember to subtract. We get negative 1v. Negative 1v squared minus v squared. So it would be negative 1 minus 1, which makes negative 2v squared. And then I got this 14 minus 15. Just don't forget those minus signs. That's minus 1. To write this in happy math lovely language, negative 2v squared minus 1v minus 1. All right, I need you to do 20, 21, 22, 24 by yourself and show me the work. Do not do 25 and 26. Thank you.